Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today in computational fluid dynamic, example of steady state diffusion, one dimensional. First, I will read the example. In a longitudinal fin of a triangular profile of length b equal to 10 centimeter and depth l equal to 1 and base of is equal to 0.92 centimeter is protruding from a wall as shown in figure. The base temperature is equal to 100 and the end is perfectly insulated, as I told you in the previous video what it means perfectly insulated. The fin is exposed to an ambient temperature of 25 if the thermal conductivity of the fin material is equal to 100 and the convection heat transfer coefficient is 40. Find the temperature distribution along this fin using the finite volume method, the one-dimensional steady-state energy equation. For this problem is given as follow. This is the steady state equation, as I told you. While there is no time factor, so this equation is the steady state. M squared is equal to 2h over k delta b. When he mean t the base when he say the base temperature, it's on here the base temperature of the fin, because the fin, it is the fin. Who don't know what this mean, where is the fin? This is the fin. He wants me to find the temperature distribution from this point to this point. Then I will start to solve it here. First, as I told you, I will convert the units to meter, and I will find delta x. Delta x is equal to length of the bar to the number of node. Number of node here I choose it 5, and you can change it whenever whatever you want. It's equal to 0.02. Then I will dividing the bar as you see. This is the node 1, 2, 3, 4, and 5. As I told you, from this point to this point is equal to delta x over 2. From this point to this point is equal to delta x over 2. While he don't say there is no heat generation, so heat generation is equal to 0. I told you how to find the x point and delta x. From here to here is equal to delta x, and from this point to this point is equal to delta x. By adding 0.02 to 0.02 I will have 0.04, and by adding and by dividing delta x, this is delta x over 2, I will have 0.01, and by adding 0.02 to 0.01 I will have 0.03. Don't know how I get this number. So I will start to integrate the equation that he gave me. This is m squared. I will find it by he gave me the equation how he gave me the relation how I can find it, to h over k delta b, and I have it's equal to 86.96. First, I will find node 1. I will integrate it from west to east, d over dx, x dt over dx, area multiplied by dx, minus also integration from west to east, m squared b t point minus t infinity a dx, by dividing it on the area, by dividing on the area, and integrate from west to east, I get this equation. And while he said is perfectly insulation, so I don't have dt over dx in the east side, I just have the west side. And by and by substitute this, and by substitute by integrate dx to delta x equal to 0, I will substitute dt over dx to the west side is equal to t point minus t west over delta x minus m square b t point minus t infinity delta x is equal to 0. And then I will separate the variable. This in the left hand side I will have the term that the variable that it have t point, and in the right hand side I have the other term, the other variable, like I don't have t is, so it's equal to 0 plus x west over delta x t west plus m square b delta x t infinity. This is the source term, so I will write the equation of it. A point t point is equal to 0 t east plus a west t west plus the source term. The source term is equal to m square b delta x t infinity. I should write on here t infinity. So sorry, I have forget to write on here t infinity, so don't forget it, please. Then I will find the node. I will find the node 2, 3, 4. Also integrated from west to east, d over dx x dt over dx a dx minus integration from west to east m square b t minus t infinity a dx. By dividing it on the area, I got x east dt over dx to the east side minus x west dt over dx west minus m square b t point minus t infinity delta x is equal to 0. And then I will substitute it. Dt over dx to the east side is equal to t east minus t point over delta x, and dt over dx to the west side is equal to t point minus t west over delta x minus m minus t infinity. To the people who don't know how it came this, every point have west side and every point have east side and west side. So at the way when I start to substitute, I will write t east minus t point over delta x and t point minus t west over delta x. I hope you understand how it came. So minus m square b t point minus t infinity delta x. Then I will also separate the variable. This is the variable that it have t points equal to the other variable in the right hand side, and then I will symbol it and it's table. The last node I have is node 5. Also I will integrate it from west to east, d over dx x dt over dx a dx, and by dividing it on the area I will have x east. I don't have a problem with east side, so x east t east minus t point over delta x minus, as I told you, I don't have x west because I have only the final length that he gave me in the question, which it is equal to 0.1. T point minus T base temperature over delta x over 2. I told you why it is delta x over 2, because the distance is delta x over 2 minus m square b delta x t point minus t infinity is equal to 0. Then I will assemble it. in a table, and then I will assemble all the table that I have in one table. This is node 1, 2, 3, 4, and 5. I assemble all of this in this table, and I will substitute its number. So this point I have in the node 1 I have x waist to its, and I have delta x which it is equal to 0.02, and a point I can find it by a west plus a east minus sp. Sp is equal to minus source term without its temperature. So I will just substitute the number in this table, and I will have this number. Then I will write the equation of this table. This is the a point. This table a point mean the point of the node, like a point 1.174 is equal to t west, which is the t2, and t east I don't have it, plus the source term, and the other in the same way. Like node 2 at the west side it's t3, and at east side it's t1. We don't know. Also for node 3 at the west side it's t4, and at the east side is t2, plus the source term. The source term mean that I will write it at B matrix that I can find from it the temperature that I want. When I write this equation in a matrix, multiply it by the temperature that I want to find, it is equal to the B matrix, which it is the source. I will find the result. You can use the scientific calculator, but here I use MATLAB program. It's more easy. You can find the result quickly. As you see, this is the result: 64, 71, 78, 86, 95. Thanks for watching.